Dear students, I am Dr. Kumar Saini, Associate Professor in Mathematics in BLJS College, Tosham. Now, today we will give lecture on vector calculus for the students of BA, BSc first year, semester second on Gauss, Green's and Stokes theorem. This is Gauss, Green's and Stokes theorem. We will give example of Gauss divergence theorem. Example 11 of this textbook, vector calculus. Evaluate double integral del cross f dot n ds, where S is the surface of the cone z equal to 2 minus under root x square plus y square, where above xy plane and f equal to x minus z I plus x cube plus yz j minus 3xy square k. Solution: since S is not a closed surface, surface x z equal 2 minus under root x square plus y square meets the xy plane, that is x equal to 0, in a circle whose equation is x square plus y square equal to 4, z equal to 0. We denote y S1 the plane region bounded by the circle. Let S be the surface consisting of the surface S and S1. Obviously S is a closed surface. By divergence theorem we have double integral or S del cross f dot n ds equal to triple integral volume del cross f dv is equal to 0. Therefore double integral over S del cross f dot n ds plus double integral over S1 del cross f dot n ds equal to 0, because S dash consists of surface surface S and S1. Or double integral over S del cross f dot n ds plus double integral over S1 del cross f dot minus k ds equal to 0. And or double integral over S del cross f dot n ds equal to double integral over S1 del cross f dot k ds. Now del cross f equal to ij k curly y curly x curly y curly z x minus z x cube, this determinant, plus yz minus 3 xy square is equal to minus 6xy minus yi plus minus 1 plus 3y square j plus 3x square k. Therefore del cross f dot k is equal to minus 6xy minus yi plus minus 1 plus 3y square j plus 3x square k dot k equal to 3x square. Therefore from second double integral S del cross f dot n ds is equal to double integral S1 3x square ds is equal to integral 0 से 2 pi integral 0 से 2 3 r square cos square theta r dr d theta, changing theta to polar coordinates, is equal to 3 integral 0 से 2 pi integral 0 से 2 r cube cos square theta dr d theta, which comes out with 3 integral 0 से 2 pi r की 4 0 से 2 cos square theta d theta is equal to 12 integral 0 से 2 pi cos square theta d theta equal to 12 pi. This is exercise. You will try to do these sums and if there is some difficulty we will discuss these sums. These are, I think, 16 in number. These are the sums. Now next theorem is Green's theorem. Green's theorem statement: if phi and psi are two scalar point functions having continuous second order derivatives in a region B bounded by a closed surface E, then triple integral volume phi del square psi minus psi del square phi dv equal to double integral s phi del psi minus psi del phi dot n ds. This is an important theorem. कुरुक्षेत्र यूनिवर्सिटी 2017 9/7 MDU 17 13 112 9 5 3 2. Green's theorem is for triple integral when we convert into the double integral. Phi and psi are two scalar point functions having continuous second order partial derivatives in a region volume B bounded by a closed surface S. Then triple integral volume phi del square psi. Del square psi is your Laplacian operator minus psi del square phi dv is equal to double integral s phi del psi is gradient psi minus psi del phi is gradient phi dot n ds. N is unit normal vector. Now proof of this theorem is given by Gauss divergence theorem. Triple integral volume del dot f dv is equal to double integral s f dot n ds. Take f equal to phi del psi so that del dot f equal to del dot phi del psi is equal to phi del dot del psi plus del phi dot del psi is equal to phi del 2 psi plus del phi dot del psi. Now f dot n is equal to phi del psi is into n dot. Using second and 3 in 1 we have triple integral over volume phi del square psi plus psi del phi dot del psi dv is equal to double integral s phi del psi dot n ds. Interchanging phi and psi we have triple integral volume psi del square phi plus del psi dot del phi dv is equal to double integral s psi del phi dot n ds. Subtracting phi from 4 we get triple integral volume phi del square psi minus psi del square phi dv is equal to double integral over s phi del psi minus psi del phi dot n ds. Note from form 4 is called Green's first identity or theorem, and form 6 is called Green's second identity or theorem. This equation number 4 is called second identity of theorem. Form 4 is called Green's first identity or theorem, and form 6, and this is form 6, is Green's second identity or theorem. Another form of Green's theorem as curly phi y curly n and curly psi y curly n denote the directional derivative phi and psi along the outward drawn normal at any point on S. Therefore del phi is equal to curly phi y curly n cap, and del psi is equal to del psi phi means gradient phi and del psi means gradient psi is equal to curly phi psi y curly n cap. Therefore phi del psi minus psi del phi is equal to phi curly psi y curly n cap minus psi curly phi y curly n cap. Phi del psi minus psi del phi dot n is equal to phi curly psi y curly n cap minus psi curly phi y curly n cap dot n cap is equal to phi curly psi y curly n minus psi curly phi y curly n. Therefore equation 6 becomes triple integral volume phi del square psi minus psi del square phi dv is equal to double integral over s phi curly psi by curly n minus psi curly phi by curly n ds. Reduction of surface integral to line integral. These two theorems, Green's theorem and Gauss divergence theorem, is we can reduce the surface integral into volume integral or volume integral into surface integral, and now we do reduction of surface integral to line integral, and this theorem is Stokes theorem. The relation between line integral and surface integral. The statement is, let S be a piecewise smooth surface bounded by a piecewise smooth single curve C, and fxyz be a continuous vector function which has continuous first order parallel derivatives in a region of space which contains S. Then integral over C f dot dr is equal to double integral S curl f dot n ds, where n cap is the unit normal vector at any point of S and is drawn in a direction in which a right hand across would advance when rotated in the direction of description of curve C. That is, this is the Stokes theorem. Circulation along C f dot dr is equal to double integral S curl f dot n ds, where S cap is let S be a statement again is let S be a piecewise smooth surface bounded by a piecewise smooth single curve C, and fxyz is be continuous vector function which has continuous first order partial derivative in a region of space which contains S. Then this hold, where n cap is the unit normal vector at any point of S and is drawn in a direction in which a right hand screw would advance when rotated in the direction of description of curve C. The proof direction of C is positive if an observer walking on boundary of S in this direction. Thank you, sir.